Hello everyone. We want to do an example on unsteady flow process. So we have an insulated tank. The volume is 8 cubic meter. Initial pressure of air inside this tank is 600 kilopascal. Temperature is 400 Kelvin. And the air starts to exit the system, and the pressure drops to 200 kilopascal, and the temperature stays constant during the process by having an element heater inside the tank. So the system is insulated, but there is a heater inside the tank which keeps the temperature constant. So initial temperature of our system is equal to the final temperature, and that is equal to 400 degree Kelvin. And so we have this information, and the goal is to calculate the electrical energy needed to keep that temperature constant. Okay, so the first thing we want to write is the mass balance. So the mass balance says that based on the equation that we had it in previous slides, mass in minus mass out is m2 minus m1, right? So I can write that equation here. So sorry about that. Let me fix this. All right, so again, so mass in minus mass out is equal to m1 minus m2, the change in the mass of our system. So is there any mass coming in? No, so that's 0, right? So this parameter is 0. So we only will be left with the final mass, which is equal to m1 minus m2. So the mass which is leaving our system, the net mass or the change in the mass of our system is equal to the difference between these two masses, right? So that's the mass balance equation. Now let's write the and if we want this mass to be positive, we can just write the change in mass of our system which escaped. The mass which is escaped our system is the difference between the initial mass and the final mass. This becomes a positive number, right? So if we write the energy balance on the other side, it's basically look at this equation. I'm just gonna look at this equation and tell you exactly how to derive that equation, right? So alright, so let's see. Is there any heat coming into the system? The answer is no. Why? Because I'm looking into this equation. So the reason is that the system is insulated, so there is no heat coming in. This parameter is 0. Is there any work being done on the system? Yes, there is an electric heater that basically puts some work into our system. So this parameter is not 0. Is there any fluid coming into our system? The answer is no, right? The fluid is only leaving our system. So this term is 0 as well because there is no fluid coming in. Is there any heat being lost? No, the system is insulated. Does your system do any work? The answer is no, because there is no work being done by the system. And is there any fluid leaving our system? The answer is yes. So far on the left hand side we only have work and sigma m theta out, right? And this sigma here means the sum of all the exit basically points from our system. So we only have one basically valve, so it's just only one, so it's just m theta, right? On the other hand, on the right side of your equation, we have basically m2 E2 minus m1 E1, right? And let's look at the energy term. So energy term is internal kinetic potential. These two parameters are ignored. It's true also for theta. These two parameters are ignored, so we will be left only by the internal energy and the enthalpy. So your equation, your energy equation, would look like something like this. We had basically work, right? So we had work in, right, to the system minus mass leaving our system multiplied by enthalpy is equal to m2 U2 minus M1 U1 because kinetic and potential energies are 0, right? So what we want to find is basically the W in, right? So that's the final parameter that we are looking for, right? But we don't have the initial mass of our system. We don't have the final mass of our system. And we don't have ME2, right? We have a relationship between these parameters. We know that ME is equal to M1 minus M2, right? We just had this equation on the top. So we need to find M1 and M2, and then ME can be found easily, right? So air is an ideal gas. We can basically use the ideal gas equation of state. M1 is P1 V1 over R T1. Initial pressure is 600 kilopascal, 8 cubic meter. And from the table A1, you can find the specific gas constant, that is 0.287. With these units of kilopascal, cubic meter, kilogram, Kelvin. Temperature is 400 Kelvin initially, so it's 41.81 kilogram. M2, we use the same equation, except that we have to use the final condition, right? So the final pressure is 200 kilopascal. The final volume is the same, right? It's a rigid tank, so the volume does not change, the overall volume of the tank. And that is 0.287. Temperature stays constant, so that's 13.94. kilogram, right? Okay, so what is ME then? ME is equal to M1 minus M2, so 41.81 minus 13.94, which is equal to 27.87 kilogram, right? So that's the final mass of our system. Now, let's look at the equation, see what other parameters do we need to find the work. So we need to find U1, we need to find U2, and we need to find the final enthalpy of our system. How to find these numbers? So there is a table inside the book. That's table, let me show you here. That's table 17, A17. And the title is Ideal Gas Properties of Air, right? So if you know the temperature of your system, then you can easily find the enthalpy and the internal energies of air, okay? So for example, in this case, we are at 400 Kelvin and we want to find the enthalpy, okay? So the enthalpy of our system at 400 Kelvin is equal to, here we look at the enthalpy, which is the second number basically, right? So 400.98. And we also need the initial internal energy and final internal energy. And if we look at basically the same temperature, because the process is a constant temperature process, so at 400 Kelvin, we can look at the internal energy, and that is 286.16. So that's the internal energy. This is the enthalpy. We use these two numbers in our equation to calculate the work, because we have every parameter, right? So U1, U2, 286.16. Enthalpy of our system is 400.98, and we have all the masses. So I'm just going to write the final answer by putting these numbers into the equation. Please check your answers, see if you get the same number. It's going to be 3200 kilojoule. So please let me know if you have any questions.